This is a PowerPoint that's going to go over two different types of naming, because we've already at this point learned two different forms of naming a compound and two different forms of writing a formula. So this PowerPoint is designed to show you the difference between the two types, because in order to properly compound name and properly write formulas, you have to know what kind of compound you're dealing with. So the first thing that I want you to know is that there are two different sets, ionic or binary molecular. Okay, that's combining the two. An ionic is the type of formula that's composed of ions, and you can tell if you have this kind of formula if the first element on your formula is a metal. Okay, if the first element is a metal or a polyatomic ion, you have an ionic formula. If the first element is a nonmetal, well, then the second element is surely going to be a nonmetal. Two elements that are both nonmetals are binary molecular or covalent formulas. So the first thing you have to do is you've got to look to see where they are located on the periodic table of the elements. So in review, if you're ionic, the first element is one of these yellow elements. It's a metal. And the second element is an element that is one of the blue elements. All right, that's a nonmetal. The other option is your first element is a yellow, and your second element is one of these polyatomic ions, and it's off that special ion chart that we memorized to learn our polyatomic ions. There is an exception. Hydrogen acts like an ion as well. So even though it's blue on this chart in both these places, it can be a part of an ionic compound. So don't forget, these are your polyatomic ions. And of course, if it's on this chart, you're definitely dealing with an ionic compound, because all of these are a list of polyatomic ions. So when you look at the periodic table, if you are on the left-hand side of a line that kind of zigzags through here under boron and at top of aluminum and then makes a zigzag motion, everybody on the left-hand side is a metal, everybody's on the right-hand side is a non-metal. If you have one of each of those, you are going to be ionic compound. So an ionic compound name follows these steps. Name the compound's cation. So the first thing you're going to do is you're going to name the cation. That's the element that is listed first. You're going to ask, is the cation in question a liar? If you say no to this answer, you're going to go directly to step 5. If you say yes to question number 2, which you're going to see on the next slide how to determine that, you're going to follow the remainder of these steps, unswitching the subscripts, checking the charge of your anion to see if you reduced, and then doing step 5. How do I answer the question number 2? I answer the question number 2, is it a liar, which is really my slang way to get you to understand, does it have more than one common oxidation state? So I think it's shorter if I say if it's a liar, because we learned an analogy where the metal was the boy and the non-metal was a girl. And we said these boy elements, these positive ion elements that had more than one charge, were lying. They don't always give the same number. So if you'll notice, scandium is not a liar. It only has one possible oxidation state. So if scandium was my cation, I would name scandium and I would proceed then directly to step number 5. However, if titanium was the first element in my compound that I'm writing the name of, so if my first element was titanium, not only would I have to write the word titanium out, I would have to leave a space for Roman numbers, because titanium does have more than one common oxidation state. So I would have to do the following steps. I would have to unswitch the subscripts. I would have to check the charges on them to see if they were reduced. I have to unswitch the charges. I have to check them to see if they were reduced, and then I will name the anion. I'm going to use the proper ending for my anion. If there's only 2 elements, the ending will be "ide." If there's a higher number of oxygen for that particular ion, it's off that orange and blue chart, the ending will be "ate." And if it was the lower number of oxygen off the orange and blue chart, my ending will be "ite." So that's how I determine if it is a liar or not. If it has only 1 charge, it's not a liar, and I proceed directly to 5. If it has more than 1 charge, it is a liar, and I have to do all 5 steps in order to figure out what Roman number I am using in the formula name. To write a compound for an ionic compound, the first thing you're going to do is name the cation. Ask, is it a liar? Unswitch the subscripts. Check if it was reduced, and end the name of my anion in "ide", "ate", or "ite". How do I tell what the charge is? Because my next part of this PowerPoint is talking about writing the formula. To know what the charge is for an element, you have to know where it lies on the periodic table. And we say for our first step in writing a formula, it's symbols and charges. For the first 2 columns, there is only 1 number. When you go look on the periodic table, there's only 1 number on these 2 tall columns. The first column, everybody's a +1, and in the second tall column, everybody's a +2. For the third column, for the ones that end up being on, when we zigzag, we go through here. Okay, so these 2 elements only have +3s on them. Okay, these elements over here are closer to the right-hand side of the chart. So this one right here, these carbon and silicon, will do both of these. It could be a +4 or a -4, depending on where it is in the formula. And the elements over here in the nonmetal section that are 1 away from the closest noble gas are all going to be -1. And if you're 2 away from your closest noble gas, you're going to be -2. And if you're 3 away from your closest noble gas, you're going to be a -3. And if you're in the girl's position and you're 4 away, you're going to be a -4. If you're in the boy's position in the formula, which means in the front of the formula, then you're going to be a +4 because you're counting in that direction. So the first step in writing a formula is symbols and charges. So that last slide was how I figured out symbols and charges. The second step is reduce if you can. If my charges were a +2 and a -4, these 2 numbers can reduce down to a 1 and a 2. So if the 2 charges can be divided by any common number, then I would reduce them. So if I had a +6 and a -3, 6 can be divided by 3 and reduces down to a 2. 3 can be divided by 3 and reduces down to a 1. So first step was symbols and charges. Second step is reduce if you can. Then once you have your charges reduced, or if they didn't reduce, once you just have your charges, you switch them to subscripts. So the element that started out having the 1 gives the element that it's bonding with the 1, which we don't write. And the element that it had the 2 is going to give it to the element it's bonding with, and we'll have a subscript of 2. You should never have superscripts in your formula at the end, because step number 3 is switch to subscripts. We never write ones. So if you're writing a subscript of a 1 in a formula, you automatically know that's wrong. All right. So, and if you have more than one polyatomic ion, those are the elements off the orange and blue chart, then those polyatomic ions have to be placed in parentheses. So the first thing you're going to do is determine the type of compound. If it is both from the nonmetal side, that's this side over here, if both things are nonmetals, then you're going to use the binary molecular compound. That is where both elements are off the nonmetal side of the periodic table. So if both elements, and they include those the gray elements here too, if both elements are nonmetals, then you are going to use the binary molecular or covalent naming system. The first element of the formula is named using the full name of the element. We don't change it to sulfide. We say sulfur if it's the first element. The second element, just like our other naming system, ends in "ide." So our second element, just like the other naming system, will end in I. I-D-E, ide. Prefixes are used to denote the number of each atom present. So I'm going to show you the prefixes on the next slide. However, mono is never used on the prefix for the first element. The first element does not get the prefix mono. However, every element, whether it's every second element will get a prefix, even if the prefix is mono. Here are the prefix lists. 1 element means mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 of them hexa, 7 hepta, 8 octa, 9 nona, 10 deca. When you're writing the formula, symbol for the element is given first. Convert the prefix to the first element into a subscript and put it after the symbol of the first element. You write the symbol for the second element given and convert its prefix for the number for the second element as a subscript and put it after the second element. So I really do need to know the location of things on my periodic table in order to decide whether I'm using the Greek naming system with the Greek prefixes, which is also called covalent naming or binary molecular, or if my first element is a metal and my second element is a nonmetal, I'm going to use the Ionic naming system. So here's some practice problems. How do I know which system to use to write the formula for iodine tetrachloride? Well, when they give you the prefixes, you really do automatically know that it is the non-metal naming system, but that does let you know that your answer to what your elements are only going to be one of these small numbers of elements in blue. So it does make it to where I don't have to look all over the periodic table because it means it does not include any of these yellow elements. Okay, so iodine, you go search out the iodine's symbol. It's an I, okay? And then the second thing I do is I am going to go look up in my mind, because you don't get to use the prefix chart. I'm going to go figure out what tetra is because it's telling me I have that many chlorides. So Cl is the symbol for that. And then tetra is 4. So that would be ICl4. So the first step I have to do is what type of molecule is this? I know it's binary molecular because they're both nonmetals. That's how I know, because both of them are nonmetals. But I also know from the tetra. So ICl4. Be careful. The font of this letter and the font of this letter are identical. although this is a capital I on your keyboard, and that is a lowercase l on your keyboard, and the computer knows the difference. All right, so I've got a formula that they've given me. It's rubidium nitrate. When I see this formula, I have to decide which kind of naming system do I use. Well, I actually don't even need to look at the periodic table, because if you have any of the 8s or ites, you know that it came off of your polyatomic oxy-ion chart. This is a chart of polyatomic ions. So since they're a list of ions, I know I'm going to use the ionic naming system. Okay, being off of this chart makes it an ion. So I'm going to write the symbol and charges, because that's the way you write a formula for an ionic name, symbols and charges. Then I'm going to reduce the charges if possible. I am going to drop them to the bottom when I switch them to subscripts. So the first step is symbols and charges. RB is a +1. It's in this first column, and that is a +1. NO3 -1 is a memorized fact, or if you're in regular chemistry, you look it up on your orange and blue chart. Because these are already reduced, there's no reducing necessary. They're both 1s. And I am going to switch. The RB is going to get the 1, which I don't write. And the NO3 is going to get the 1, which I also don't write. So I don't write 1s in my formulas. So RB gets the 1, which I don't write, and NO3 gets the 1, which I don't write. All right. How do I know which formula system I have a compound name for? For me, for this one, I know that they've given me prefixes. So that just helps me know that it's going to be off of the chart. Both of them are going to be on this side. It'll help me answer what is the formula quicker, because I know I only have to look on the blue section of the periodic table, and I don't have to scour through all the elements on the periodic table. So the type of molecule that involves prefixes is binary molecular molecules. Binary molecular molecules are made up of 2 non-metals and utilize the prefix system. So I write the name of the element's symbol, and I know the prefix. It is then a subscript. I write the element symbol, being careful to use an L and not an I, and I write the prefix. So the formula for this element, after I solve my problem, is S2Cl2. Which system do I use for SrSO4? Hopefully you notice that SO4 involves something that's polyatomic. If it involves something that's polyatomic, I know that it is the ionic naming system, which means my first step is to write the name of the first cation. Sr here is the first cation. That's named strontium. The second step is to ask, is strontium a liar? So you've got to go look and find strontium on the periodic table to see if it is in a box that has more than one common oxidation state. So that's what I'm asking when it's a liar. If you go look up strontium, you'll see on his box, he only has above the symbol for strontium, only has a +2 charge. It's the only number there. So now I get to skip. Because if number 2 is that it's not a liar, I get to skip down to number 5, because I'm not going to have Roman numbers in this formula. So you're going to skip to 5. And then the last thing's name is sulfate. It's sulfate. So the answer to this is strontium sulfate. There's no Roman number here because strontium is not a liar. It's not a liar. How do I know which system to use to write the formula for dichlorine heptaoxide? It's just heptaoxide. There's no A in there. What is the type of molecule that I have? It is off of both of these things are nonmetals. My biggest indicator for this is that it has prefixes, and the prefixes let me know that this is a binary molecular compound. So to write the formula for it, and how do I know? It's because of the prefixes and they're both nonmetals. So to write the formula for this, I write the symbol for the element they gave me, Cl. I utilize the prefix system, 2, and oxygen is the O. I utilize the prefix system, and then, oh, this is going to have a typo. Hepta is 7, so this is a typo. Please disregard that and make it a 7 in your mind. Okay, that's a 7. So what naming system do I use here? I use the naming system that utilizes the polyatomic oxy-ion list because since it is on the chart, I know it's an ion. So I write the name of the cation. It's cobalt. I ask, is cobalt a liar? The answer to that question is yeah. When I go look at cobalt, it has more than one common oxidation number. If I go look on the periodic table and I find the square for cobalt, you'll be able to see on that chart that it has both a +2 and a +3 number. That means that cobalt requires you to have a parenthesis with a Roman number. Now, the parenthesis is actually optional. I just mentally place one there because I know I'm going to need to have a Roman number in this formula. So the next thing is I have to uncrisscross them to see what is the lie that cobalt said here. So uncrisscross these elements. It looks like the ASO3 gave a 3 charge. And if that's true, then the cobalt gave a 2 charge. So when you look up on the polyatomic chart, is ASO3 a -3? If it is, then nobody got reduced. You have to look at the unswitch. You got to look at the unswitch, and then you have to go look to see if the ASO3, if it is indeed a 3. And in this case, ASO3 is a -3. So then I know that the cobalt here was in fact the +2. So the last name to this ASO3 is arsenite. So my name is cobalt, Roman number 2, arsenite. And the parentheses are optional. I do not have to have the parentheses on that element when I write the formula. So when it was off the polyatomic chart, that's where I went to go look what its charge was. Actually, if you're in honors chemistry, you've memorized that. All right, so I want to write the formula for this. When I go look up barium, I find out that it is metallic, so it's going to be utilizing the Ionic naming system. I write symbols in charges. I reduce the charges if I can. That's a 2, that's a 3. They don't reduce. And then I drop them to the bottom when I switch them. I switch to subscripts. Please do not leave them as superscripts. So you can't reduce them, and they switch down to subscripts. So the BA gets the 3, and the PO3 gets the 2. And because this number is not a number 1, I'm going to need parentheses to keep it straight that I have 2 of the PO3 ions. Be sure that you have parentheses when you have more than one polyatomic. How do I know which naming system I use to write the compound name for I2O3? You go look on the periodic table to find out what kind of molecule is this. Both of these are nonmetals, so it's binary molecular. I know that by looking at the periodic table and see that they're both nonmetal elements. When they're both nonmetal elements, you're going to use the prefix naming system. So what is the name for this first element and what's the prefix? It's di and iodine. What is the name for this part of the compound? It's tri, and then you have to change the ending of oxygen to oxide. So it's diiodine trioxide. How do I know which naming system to use? N2Br4. What type of molecule is this? Where are these elements on the periodic table? They're both nonmetals. So this is a binary molecular formula. So how do I know? They're both off the right-hand side of the periodic table. So when I solve this compound's name, I use the prefix system. The name of it is dinitrogen tetrabromide. What is the name of this compound? The first thing I have to do is find out what kind of compound is this. When I go look up MO off the periodic table, I find that it is a metal, which means it is the Ionic naming system. When I write that, I have to write the name of the element first. And I ask, is that element, molybdenum, a liar? The answer to that question is yes. So since it is a liar and it does have more than one oxidation state, I am going to have to find out what lie it made. So I'm going to uncrisscross the numbers that this element shared. So it looks like the P gave a 1. And if that's true, then the MO gave a 2. So is that true? Is it true that the element is P is a -1? And the answer to that question is no, it's not. So I have to check to see what is the charge of P. That's a -3. So how do I unreduce this? The 2, to get this number back, gets times by 3 over here. And to get the number back over here, it's going to get times by 3. So the original number on that element was a 6. It was a +6. So you always check the girl or your anion, because the girls don't ever lie about their charges. And so I am going to uncrisscross that to answer the question, what is the name of this formula? Molybdenum 6 phosphide. Okay.